All right, let's jump right in. Today, we're going to unpack one of the most important white papers to come out in the blockchain space, Chainlink 2.0. And let me tell you, this is way more than just a simple update. It's really a blueprint for a completely new generation of smart contracts. So, what's the big idea here? Let's get into it. So, at the very heart of all this is one simple but really powerful idea. Smart contracts are code that you can trust, period. Once you deploy one on a blockchain, it runs exactly as it's written. There's no downtime, no censorship, no one can just come in and change the rules. It's basically an unbreakable digital agreement. Okay, but here's the catch, right? That incredible security, it comes with a pretty big price. A smart contract is, for all intents and purposes, trapped inside its blockchain. It has no idea what's happening in the real world. It can't check a stock price, it can't connect to a banking API, it can't do any heavy-duty math. So you have to ask, what good is all that trust if it's stuck in a box? And this is the central problem that the white paper just tackles head on. They call it the smart contract paradox. The very thing that makes these contracts so secure, the fact that they're isolated on chain, is also their single biggest weakness. They're blind to the outside world, which means they can't react to, market data, sports scores, or shipping updates, which kind of makes them not very, smart. And you can really see the trade-offs laid out here. On chain, what do you get? You get that unbreakable security, you get transparent asset management. That's awesome. But the limitations are just massive. They're isolated from real-world data, they're super slow and expensive to run, and they have zero confidentiality. If we're going to build the kinds of apps we all dream about, we have to fix this. And this is where we get to the core innovation of Chainlink 2.0. The solution isn't just about feeding in more data anymore. No, it's about building something way, way bigger, a decentralized Oracle network, or what they call a DAWN. So what in the world is a DAWN? Well, think of it like a supercharged Oracle network. It's a whole committee of nodes that does way more than just fetch data. The key word here is compute-enabled. It acts as a full-blown computation layer, a secure, two-way bridge that connects smart contracts to literally any off-chain system. We're talking a huge leap past just simple price feeds. And you can see how it works right here. A DAWN gives a smart contract the three things any real computer needs. It gives it networking, using these adapters to talk to web servers and other blockchains. It gives it computation, which happens securely off-chain. And it even gives it storage. It's basically an entire off-chain computer infrastructure, built from the ground up just for smart contracts. So you have this powerful new tool. How does it all come together? Well, with DAWNs, we can now create a totally new kind of application, the hybrid smart contract. And the name says it all. It's about combining the very best of the on-chain world with the best of the off-chain world into one seamless, powerful application. Okay, now this is a really important concept to grasp. A hybrid contract basically splits the work. It has two parts. You've got the on-chain smart contract, the SC, which does what blockchains are amazing at, holding assets securely and being that final source of truth. And then you have the off-chain exec part that runs on the DAWN. This is the workhorse. It does all the heavy lifting, all the computation, the data fetching, before it reports a single simple answer back to the chain. So here's how that workflow actually plays out. The on-chain contract, the part that's slow but super secure, it just holds onto the valuable assets. Whenever it needs to do something complex or data-heavy, it just calls out to the off-chain DAWN. The DAWN goes to work, does all its calculations, fetches whatever data it needs, and then securely reports that one final, distilled result back to the chain. The on-chain contract then only has to do one simple, cheap transaction based on that trusted answer. It's incredibly efficient. And this hybrid architecture, it's not just some theory on a white paper. It actually unlocks a whole set of new superpowers for decentralized apps. So let's take a look at what this actually makes possible. First up, a big one, scaling. Just look at the difference here. On the left, in A, every single little transaction has to hit the main blockchain. That gets slow, it gets expensive, and it gets clogged up fast. But on the right, in B, the DAWN can process a huge batch of transactions off-chain and then just send a single summary back to the main chain. This boosts speed and slashes costs. It's almost like a built-in scaling solution for the whole blockchain. Next, and this is absolutely huge, is confidentiality. Blockchains are public. Everything's out in the open, and that's a major roadblock for a lot of use cases. But with this setup, sensitive data can be processed privately inside the DAWN. Only the final output ever touches the public chain. The raw data itself is never exposed, which suddenly opens the door for things that need privacy, like decentralized ID systems or private business transactions. Okay, let's talk about fairness. One of the dirty little secrets of DeFi is a problem called front running. As you can see in panel A, a miner or a validator can see your transaction coming, and they can actually reorder the transactions to profit at your expense. It's not great. But check out panel B. A Dawn can run what's called a fair sequencing service, or FSS. This service basically acts as a neutral referee, guaranteeing that transactions are processed in the exact order they were received. It creates a truly fair and level playing field for everyone. And finally, let's talk security. The white paper introduces this really powerful idea called super linear staking. Now, it sounds super complicated, but the core concept is actually pretty simple. All it means is that as the network gets bigger, the cost to attack it goes up exponentially. So if you double the number of nodes, it doesn't just get twice as hard to corrupt the network. It might get 10 or even 100 times harder. The cost to attack just skyrockets, making it practically impossible to bribe. So, when you put it all together, scaling, confidentiality, fairness, and this new level of security, where does this all lead? Well, the white paper paints this incredible long-term vision of what they call a decentralized meta layer. The whole point is to eventually hide all of this crazy complexity from developers. And I love this quote because it comes straight from the source. Their ambition is a decentralized meta layer. What does that mean? It means creating a system that's so easy to use that developers won't even have to think about what's on-chain versus off-chain. They won't have to worry about which blockchain they're on. It'll all just work. And this right here, this is the ultimate goal. Imagine a future where a developer just specifies what they want their app to do, in plain terms. Then a compiler just automatically figures out everything else and generates all the pieces. The on-chain contracts, the off-chain dons, all the connections. It's like having an entire team of world-class blockchain engineers ready to turn your idea into a fully built, secure application instantly. Which, of course, leaves us with one last, really fascinating question. The vision of Chainlink 2.0 isn't just about making better oracles. It's about tearing down the barriers to building these sophisticated, secure, globally connected apps. So if building on blockchain becomes this easy, if we can finally combine the absolute trust of the chain with the infinite power of the off-chain world, what are we going to build next?